Prac 1 by Samuel Bate and Lewis Jones. The first part of the Prac was about determining the variety of qualities of the soil. The first tests conducted in this part were ones to measure the gravimetric water content, and the second were 4-cone tests used to determine the soil shear strength. These tests were conducted as follows. This is us scooping our 80% sample. This is the 80% sample in the microwave. This is the weighing of the sample. And putting the soil sample into the container as shown. This is the test for 50%. These processes were then repeated for the other 5 samples.
In the conclusion of experiment 1, it was discovered that the water content of the soil influenced the depth result in the penetration test. A positive correlation was found where the higher the water content, the greater the depth height. This is due to the fact that the water is more easily displaced than soil grains, and thus the soils with greater water content will have greater overall displacement. The workability was also found to be higher in the soil specimens with greater water content, as they were more easily physically manipulated compared to the lower water content soils. The dry unit weight change was greater in the soil specimens with a higher water content. This is caused by the fact that the soils with the higher water content have a greater portion of their mass taken up by water. When the specimen is placed in the oven and dried, the soils with the greater water content essentially have a larger amount of mass to lose, as only soil should remain in theory. It should be noted that due to time constraints, we were forced to only dry for 1 minute, which could have diminished the trend. Generally, as the shear strength of the soil specimens decrease, the water content increases, while the dry unit weight decreases. The first relationship can be explained by the fact that the clay and fine soils with higher water content have the greater amount of water to displace. This makes the soil less resistant to force. So as the water content increases, it is expected that the shear strength decreases. For the second relationship, a decrease in water content resulted in a decrease in the penetration test result. According to the formula for shear strength, it is equal to the proportionality factor multiplied by the weight of the cone divided by the penetration depth squared. So as the penetration depth increases, so does the shear strength, and as penetration depth increases, so too does the dry unit weight. Thus, it can be said that as the dry unit weight increases, shear strength increases along with it.
Part of this Prac involved comparing 2 types of embankment dam, one with drainage gravel and one without. This is us creating the embankment dam with homogeneous material, like shown. And now we get to see what happens. Dam is starting to fill quite rapidly now. For the homogeneous dam, when the water reached the downstream side of the dam, the water eroded the downstream side of the dam from the base up to the height of the water. Subsequently, the dam fouled quite quickly. This is our setup, all ready to put in the gravel in the little triangle that we see here. Here's gravel being placed in a little triangle that I showed you earlier. This is the video of our dam with our drainage gravel at the left side. For the embankment dam with drainage, when the water reached the downstream side of the dam, instead of flowing through the embankment, most of the water was channeled through the gravel drainage at the base. Consequently, the dam did not erode up to the high water level. The reason for this is because the gravel is less tightly packed than the sand. The primary reason for this occurring is because gravel is coarse, while the sand is quite fine. When water flows through the system, the water will flow to an area where fluid motion is less hindered. This occurs because fluid flow from an area of high pressure to an area of low pressure, and low pressures occur at higher velocities. Returning back to the soil mechanics part of the question, thanks to basic geometry, there are more empty spaces in coarse soil samples, such as gravel, compared to fine soil samples, such as sand. This extra space allows for more water to flow through the coarse gravel and hence increases the velocity of the water. The subsequent drop in pressure attracts the water away from coming out of the dam and instead gets most of the water flow to come out via the gravel drainage, as shown in the video.